So we're doing these three integrals. The first one is the integral of 1 over the square root of 4 minus x squared dx. Looking at it, you have to try and figure out what sort of function it is. And we recognise that's standard form for a sine inverse. Because there's a 4 in there, we know a squared equals 4, so a is going to equal 2. So it's sine inverse of x on 2. And we have terminals 0 and 1. And so we're going to substitute x equals 1 and x equals 0 into this integral. So the first thing we're going to write down will be sine inverse of 1 over 2, and then subtract sine inverse of 0 over 2. And of course 0 over 2 is 0 and sine inverse of 0 is 0. So then we're left with sine inverse of a half. Sine inverse of a half is pi on 6. The second one, the integral of 1 over 4 plus x squared. Now, 1 over 4 plus x squared is not a standard integral as it stands. Because there's no square root, we know it's going to be a tan. But the tan has a facet formula. It's a over a squared plus x squared. So for this to be a tan inverse, we need to have a 2 on the top. But I can't put a 2 on the top unless I decide to cancel that out with a half. The half and the 2 cancel each other out. And now we have a standard tan inverse formula. And so that's tan inverse of x on a, which in this case will be tan inverse of x over 2. And again, we've got terminals of 2 and 0. And so we're going to substitute those numbers in. It's a half tan inverse of 2 on 2 minus a half tan inverse of 0 on 2. And of course 0 on 2 is 0, tan inverse of 0 is 0. Now we know from exact angles the tan inverse of 1 is pi on 4. So this is going to be 1 half of pi on 4, which gives you pi over 8. Number C. Now this is a very difficult one to do because as looking at it, it doesn't look like any standard integral that we know. It has got a square root in there, so we know it's going to be a sine inverse. However, if it's going to be a sine inverse, we can't have the 4 in front of that x squared. That's not standard form. So what we need to do is take that 4 out. We can also take the 3 out, which then gives us the 1 on top. So it's going to be 1 square root. Now, I'm going to take the 4 out. So that leaves me with 9 on 4 minus x squared, all in brackets, multiplied by 4. And you note that the 4 is underneath the square root sign. So, square root of 4 becomes 2, so that 4 is now gone, and it's 1 over the square root of 9 on 4 minus x squared. This is the stock standard form for a sine inverse. And it's going to equal 3 on 2 sine inverse of x over 3 on 2, which becomes 2x on 3 between 0 and 1. And you need to remember and not be tricked by that. So a squared is 9 on 4, a is 3 on 2, x divided by 3 on 2 is 2x over 3. And then we recognise that we've got terminals of 1 and 0. So what we're going to do now is we're going to substitute the 1 in, and we're going to substitute the 0 in. And so this is going to equal 3 on 2 sine inverse of 2/3 minus sine inverse of 0. Sine inverse of 0 cancels out, of course, and so we're left with the answer being 3 on 2 sine inverse 2/3. And of course it would be the answer in exact form. But of course, if the question asks you to use that answer or to simplify it to some decimal places, then you could approximate that to 1.095. Now, it's really, really important that you understand and look at the different formats. You have to be able to recognize what gives you a sine inverse, what gives you a cos inverse, what gives you a tan inverse. And with lots and lots of practice, you should be able to do this very, very quickly.